Welcome to all the students in chemistry lecture series. This is lecture 6. In previous lecture, we will discuss the structural isomerism. In structural isomerism, there are three types of structural isomerism. The first is ionization isomerism, the second is linkage isomerism, and the third is the coordination isomerism. In this topic or in this lecture, we will discuss the stereo isomerism. So first of all, we will see what is meant by stereo isomerism. These isomers contain same atoms. These isomers contain same atom and atom to atom bonding is same but different only in the spatial arrangement of atom around the central middle atom. This is called as the stereo isomerism. Stereo isomerism means these are the isomers contain same atoms and atom to atom bonding is also the same but differ only in the spatial arrangement of atoms or group around the central metal atom is a different. For example, octahedral complexes central metal atom is the same but atom is the same फक्त अरेंजमेंट ऑफ लिगँड्स त्याची जी काही अरेंजमेंट ऑफ लिगँडची असेल मग ती कोणत्या फॉर्म मध्ये असेल सिस फॉर्म मध्ये असेल किंवा ट्रान्स फॉर्म मध्ये असेल फक्त त्याची स्पेशल अरेंजमेंट जी असते ती कशी असते वेगळी असते आणि जिथं स्पेशल अरेंजमेंट वेगळी असेल तर तशा आयसोमेरिझमला काय म्हणतो आपण दिस टाइप ऑफ आयसोमेरिझम कॉल्ड एज द स्टेरिओ आयसोमेरिझम. बॉन्डिंग सेम असणार बॉन्डिंग मध्ये कोणता डिफरन्स नसणार फक्त त्याच्या अरेंजमेंट मध्ये काय असेल डिफरन्स असेल मग एक कोणतं सिस पोझिशनला असेल दुसरा ट्रान्स पोझिशनला असेल ते सेम पोझिशन असेल किंवा अपोजिट पोझिशनला असतील असं जिथं आढळलं तर अशा काय म्हणतो आपण these are called as the stereo isomerism. These isomerism contain same atom or atom to atom bonding but differ only in the spatial arrangement of atom around the central metal atom is called as the stereoisomerism. In this stereoisomerism is possible only in the coordination compound 4 and the coordination compound 6. Your coordination number compound 4 and coordination compound number 6 and the 4. So first of all, stereoisomerism, there are two types of stereoisomerism. The first is called as the geometrical isomerism and the second is called as the optical isomerism. So first we will discuss the geometrical isomerism. So the geometrical isomerism means this type of stereoisomerism or this type of stereoisomerism arises in the coordination compound due to difference in geometrical means positional difference in geometrical or the positional arrangement of ligand around the central middle atom is called as the geometrical isomerism. Geometrical isomerism, why it is arises? This type of stereoisomerism arises in the coordination compound due to the geometrical or त्यालाच काय म्हणतो आपण positional arrangement of ligand around the central middle atom is called as the geometrical isomerism. याचा अर्थ काय आहे की ज्याची काही जी लिगँडची जी पोझिशन असते ती कशी असते पोझिशन इज डिफरंट और अटॅचमेंट ऑफ पोझिशन इज डिफरंट इन वन कंपाउंड इट इज सीन एज अ सिस इन अदर कंपाउंड इट शोज द ट्रांस. This type of arrangement is called as the geometrical isomerism. So first of all, what is the cis form? When similar kind of ligand attach or adjacent to each other, this type is called as the cis form. And when transform is occurred when the similar kind of ligand on the octahedron or the square pillar complexes they are opposite to each other. For example, here I see here geometrical isomerism in octahedral complexes cis form and transform how they are occurred. Cis form means similar kind of ligand adjacent to each other and transform or in a transform similar kind of ligands opposite to each other. This is called as the cis form and the transform. So first of all, see here first the geometrical isomerism in octahedral complexes having the coordination number 6. Those compounds having the coordination number 6 having the geometry is the octahedral geometry. See here the in coordination compound or coordination number 6 there are the cis position and the trans position. In this compound 6 position occurs 9 position is present in a octahedral complexes. 6 coordination compound or in this compound or the coordination number 6 compound consists of the 9 cis position and 3, only 3 is the transposition. Which is 9 position? So first see here, L1 to L2, this is first cis position. Then L2 to L3, this is second cis position. Then L1 to L3, this is the third cis position. Then L3, L4, fourth. Then L3, L5, fifth. Then L4, L5, sixth. Then L5, L6, 7. Then L1, L5, 8, and L6 to L2. These are the 9 6 position, or the 9 6 position arises in a geometrical isomerism or the octahedral complexes. 6 position means similar kind of ligand. This is same ligand, this is same ligand. On the addition to each other is called as the cis form. When this ligand, see here, 9 6 position occurring in octahedral complexes, and only 3 position, or the only 3 position is a transposition. Which is transposition? L1 is trans to L4. L1 is trans to L4. Why it is? Because these are opposite to each other. This is the first position. Then L2 is trans to the L5. This is transposition, and L6 is trans to the L3. This is called as a transposition. This is same kind of ligand attached to the opposite side. Same kind of ligand attached to the opposite side, and same kind of ligand attached to the opposite side. These are only, or it shows only 3 type of the 3 transposition, but shows the 9 6 position, 9 6 position. 1, 2, 3, 4, 5, then 6, 7, 8, and 9. These are the 9 6 position, and the only 3 is the transposition. Geometrical isomerism in octahedral complexes having coordination compound 4 are divided into the 3 types. The first type is called as the MA4. See here the 3 types of geometrical isomerism in coordination compound or coordination number 6, that is in octahedral complexes. The first type is MA4B2 or MA4B2 type of the complexes. In A4B2 type of complexes or A4BC, it means that A or B, this is the monodentate ligand. A means monodentate ligand, and another ligand is called as B, is called as a different ligand. Means A4, same kind of 4 ligand, and 2 different ligand. Same kind of 4 ligand, same kind of 2 different but same 2 ligand. The example of A4B2, this is the CONH4Cl2. CONH4Cl2. See here, this is called as the M means central meta atoms, 4 means A4 means similar kind of 4 ligand, and B2 means similar kind of anionic ligands or ionic ligands is called the Cl2. This is the Cl2 means B2, and this 4 means similar kind of 4 ligand, that is A4. The another complex is a MA4BC. In this the same kind of ligand 4 and BC. B means different ligand Cl, and another is a Br. These complexes MA4B2 or MA4BC shows the 2 types of the geometrical isomerism. The first isomerism is called as the cis form, and the second isomerism is called as the transform. See here, in a cis form, similar kind of ligand means 2 Cl atoms or 2 Cl atoms. 2 Cl atoms is present adjacent to each other in octahedron or corner. This is one Cl and this is another Cl. Same kind of ligand adjacent to each other. Hence, this form is called as the cis form, or the 2 chlorine ligands adjacent to each other is called as the cis form. But in a trans form, 2 chlorine or the same kind of ligand, 2 chlorine atoms or these 2 Cl ligand is opposite to each other on octahedron. When they are present near to each other or adjacent to each other, then this form is called as the cis form. When these 2 similar kind of ligand or 2 chlorine atoms, similar kind of ligand, opposite to each other on octahedron, it is called as the transform. Hence, MA4BC compound or MA4BC type of complexes shows the 2 types of isomerism. The first is the cis form and the second is the transform. In first cis form, two similar kind of ligand or two chlorine atoms adjacent to each other on octahedron. Hence, this form is called as the cis form. And in trans form, two chlorine atoms opposite to each other on octahedron. Hence, this form is called as the trans form. Then second type is called as the Ma3B3. Ma3B3 complexes. In this Ma3B3, A3 means 3 ligands, same type of ligand A, and B3 means another 3 ligands, they are also the same types. The example of Ma3B3, CONS3Cl3. See here, M means central metal atoms, here is the cobalt is the central metal atoms. A3 means similar kind of 3 ligands of ammonia, these 3 ligands A, and another B3 means the 3 chlorine atoms, or the 3 same kind of ligand is the chlorine atoms. On octahedron, when these 3 types of chlorine atoms or these type of ammonia molecules, see here, 3 types of ammonia molecules, 1, 2 and 3, they are adjacent to each other on octahedron. 3 types of ligand adjacent to each other on octahedron. This type of isomerism is called as the facial isomerism. In A3B3, when 3 kind of ligands adjacent to each other on octahedral faces, hence this is called as the facial arrangement or it is also called as the fat isomers. See here, the 3 types of ligand, chlorine and chlorine, they are adjacent to each other. Hence, facial arrangement or the facial arrangement is a same facial arrangement on the octahedron. Hence, this is called as the facial or the fat isomerism. Or the second, the 3 type of ligands. Here is NH3, here is NH3, another NH3. They are in a second they are not on a similar kind of, they are not arranged adjacent to each other. It means that they are called as the meridional or the mer isomer. When they are present adjacent to each other, or 3 ligands, same kind of ligand adjacent to each other present on octahedral faces, is called as the facial isomerism or the fat isomers. But they are not present on the similar, or they are not present on the near, or the not adjacent to each other, then it is called as the meridional or the mer isomer. In short, it is called as the mer isomer. This is the example, or the Ma3B3 complexes shows the 2 types of isomerism. The first is called as the facial isomerism and the second is called as the meridional isomerism. When the similar kind of ligands adjacent to each other on octahedral faces, that time it is called as the facial or the fat isomer. When they are not present adjacent to each other, then it is called as the meridional or the mer isomer. Then the last example of this type, MAA2B2. In this MAA2B2 complexes, see here which example here taken, MAA2B2. In MAA2B2 complexes, these are also shows the 2 types of isomerism. The first is the cis isomerism and the second is the trans isomerism. This is about the third type, MAA2B2. M means central metal atom, MAA2B2. It means that MAA means M is the central metal atom, MAA means similar kind of, it is called as the symmetrical bidentate ligand, and B2 means different monodentate ligand. For example of this, CO, En2, Cl2, CO, En2, Cl2. This type of the complex shows positive charge 1. See here. MAA2B2, for example, COEN2, Cl2 positive complexes. See here, this type of complexes in this MAA2 means the bidentate ligand, but symmetrical bidentate ligand. Symmetrical bidentate ligands, for example, NH2, CH2, CH2, NH2. CH2 CH2 NH2 is called as the symmetrical bidentate ligand. Symmetrical means they are divided into two same half or they are divided into the two same half. This is called as the ethylene diamine. Then oxalic acid COO negative or COO negative. This is the oxalate ion. This is also the example of the symmetrical bidentate ligand because we are divided into the two similar groups. Then MAE2 means symmetrical bidentate ligand. Symmetrical bidentate ligand, and B2 means the another monodentate ligand. These isomers also show the two types of the isomers, or this shows the two types of isomers. The first is called as the cis isomer and the second is called as the trans isomer. CF. This complex shows the cis isomer first. Here, coordination compounds central atoms is a CO, then EN, ethylene diamine, and two chlorine atoms Cl. Two chlorine atoms Cl. This is called as the cis isomer or cis form. In cis form, two similar kind of ligands, similar kind of chlorine atoms, they are the same places or they are addition to each other, is called as the cis form. In trans form, they are opposite to each other. See here, this is the octahedral case. CO, same kind of ligand, opposite to each other, chlorine, ethylene diamine, EN, ethylene diamine. This is the positive part. It is called as the trans form. It means that MAE2B2 type of complexes give the two types of form. One is a cis form and another is the trans form. In a cis form, two similar kind of ligand, or these two similar kind of ligand, they are present on octahedral faces. They are the adjacent to each other. Hence, it is called as the cis form. In trans form, two similar kind of ligand or two chlorine atoms. They are the similar kind of ligand or two chlorine atoms. They are opposite to each other. Hence, this is called as the trans form. Trans means similar kind of ligand attached opposite to each other, and cis means the similar kind of ligands adjacent to each other. This is the three types of complexes, or this is the geometrical isomerism in coordination compound 6. They show the three types of complexes. The first type is called as the MA2B2 complexes, then MA3B3 complexes, and the third type is MAA2B2. These three different types show the cis and trans complexes. The first MA2B2 shows the cis and trans complexes or cis and trans form. When second type MA3B3 shows the cis trans, but difference name of that is the difference, the spatial arrangement and the meridional arrangement. And the third complex is MAA2B2 shows the two types of two forms, that is the cis form and the trans form of the geometrical complexes.